All right, guys, welcome to day 4, proving quadrilaterals are parallelograms. We have quite a bit of vocabulary and terminology again today, so some patience here, and be prepared to jot down more than usual volume of words. So first of all, let's revisit the definition of a parallelogram, and we say that if both pairs of opposite sides are parallel to the corresponding opposite side, then it is a parallelogram. So we'll just abbreviate that. We'll say both pairs of opposite sides are parallel to the corresponding opposite side. Corresponding opposite side. And we already alluded to this in our day 3 video, but the idea is that, okay, side BC and AD, they're parallel, they're opposite one another and would be considered corresponding. And then the other set would be CD and BA. Okay, and then next we're going to discuss the converse opposite side parallelogram theorem, which has a lot of words there. And this is saying that if both pairs of opposite sides are congruent, so if I know that CB and AD, for example, are congruent, and then CD and BA are congruent, then we can determine that it is a parallelogram. So if both pairs of opposite sides are congruent to the corresponding opposite side, in a quadrilateral, of course, then it is a parallelogram. Then it is a parallelogram. There we go. Okay, and then next we have a similar concept where we're inspecting the angles. So the converse opposite angle parallelogram theorem states that if both pairs of opposite angles are congruent, so B and D, if we know that those two are congruent, and angles A and C, then we know that it is a parallelogram. So if both pairs of opposite angles are congruent to the corresponding opposite angle, in a quadrilateral, then it is a parallelogram. It is a parallelogram. So pretty much if we know that it has to be a parallelogram if those opposite angles are the same measure. Okay, next we have the converse consecutive angles parallelogram theorem. And this is basically saying if one angle of a quadrilateral is supplementary to both of the angles on its sides, then it's a parallelogram. So if I know that angle A is supplementary with B, and it's also supplementary with D, and both of those criteria have to be met, then we know it's a parallelogram. Okay, so we'll say if one angle, told you there are a lot of words here today, guys. If one angle of a quadrilateral is supplementary to both of the angles on its side. Remember, it has to be both, not just one. Both of the angles on its sides, then it's a parallelogram. Then it is a parallelogram. almost put another L in there. Okay. And a discussion on parallelograms would not be complete if we didn't visit the diagonals. So the converse diagonals of a parallelogram theorem. This is saying if the diagonals of a quadrilateral bisect each other, it has to be a parallelogram. So we talked about, like, if I drew these two diagonals, if they're cutting each other perfectly in half, then I know it's a parallelogram. So if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. Then it is a parallelogram. Boom. Okay, and that takes us to our last one, which is the parallel and congruent parallelogram theorem. That sounds pretty pretentious to me. So if one pair of opposite sides are congruent and parallel, then it's a parallelogram. So before we said, as long as we knew both of the opposite sides, but like both pairs have to be congruent. But if we only know that one side is congruent, or we should say one pair is congruent, but we also know they're parallel, then we know it's a parallelogram. So like if, for example, we only knew that BC and AD are congruent, but we also had that extra criteria that they are parallel, then we can conclude that it is a parallelogram. So if one pair of opposite sides are congruent and parallel, then it is a parallelogram. It is a parallelogram. And that's it. Okay, so now we have all of those theorems. Let's apply them. Okay, so we're going to determine if each of these quadrilaterals are parallelograms or not. So essentially, are any of those theorems being met that we just discussed? So first scenario, from the markings, we can see that this pair of opposite sides are congruent. And then we also have this pair of opposite sides, which are congruent. So because that was one of my theorems, right, I can say, yes, this is a parallelogram because it has two pairs of opposite congruent sides. And this means it satisfies, so we'll say yes, according to the converse opposite side parallelogram theorem. Converse opposite side parallelogram theorem. So again, if we know those two pairs of opposite sides are congruent, then we know it has to be a parallelogram. Okay, next one. The only information that we are given here is that these two sides are parallel. We don't even know if they're congruent or not. So this is not sufficient. If we knew that they were also congruent, then we could say that it's a parallelogram. Or if we had some more information, but we'll just say not enough information. So we cannot conclude that. Cool. Number 3, this is kind of the example I was just mentioning. We know these two sides, so this pair of opposite sides, they are not only parallel, but they're also congruent. So we would say yes. So because we have those criteria met, this satisfies, oh my goodness, satisfies the parallel and congruent parallelogram theorem. Parallelogram theorem. Because parallel and congruent criteria are met. Okay, number 4, for looking at the information here, we see that we have two angles which are congruent. Those are my opposite angles. Okay, and we see that with respect to this angle here, 138 is also supplementary to both of the angles on its sides. So actually, that's the criteria that we could go off of. So this, we would say, yes, this is a parallelogram according, or satisfies, according to the converse consecutive, such long names, angle of a parallelogram, angle of a parallelogram theorem. Cool. Okay, number 5. Notice now we have an angle of 102 and angle J is 102, so those are opposite angles which are congruent. Then also I have angle K and angle H, which are both 78 degrees, opposite angles, and they are congruent, right? So this would also be enough information. So we could again say yes, and this satisfies the converse opposite angles of a parallelogram theorem. Converse opposite angles of a parallelogram theorem. Cool. Okay, we see that number 6 is pulling in some information on the diagonals. So we know that this diagonal is bisected by the other diagonal, but there's no information pertaining to the smaller diagonal. Remember that they need to bisect each other for that to be sufficient. And then it looks like they are telling us that these opposite sides are congruent. So it almost seems like we have so much information, like a plethora of information, but that's not, they're coming from different theorems. So they're like half-satisfied theorems. 2 half-satisfied theorems does not make a fully single satisfied theorem. So we would say that this is not sufficient information. So not enough information. Cool. Okay, and then as has been the case, it wouldn't be a complete lesson without some algebra. So we're going to be solving for the following variables so that we confirm the quadrilateral is a parallelogram. So if I'm looking at number 7, if I wanted this to be a parallelogram, I would need to have these 2 opposite sides be congruent. And in order for them to be congruent, I would have to set the expressions equal. So 7x minus 12 equals 5x plus 6. And then if I'm solving, I could subtract 5x from both sides, canceling here, giving me 2x minus 12 equals 6. I would then want to add 12 to both sides, giving me 2x equals 18. And I'd want to divide both sides by 2, giving me x equals 9. And that's it. Next one. In order for this to be a parallelogram, I want my opposite angles to be congruent. So I know that these 2 angles have to be congruent, and these 2 angles have to be congruent, right? I'm kind of limited as far as things to set equal, because if I were to try to set equal 3y and 4x, I couldn't solve. I'd be kind of at a standstill because those are different variables. But I do know that the red and the green angles all have to be supplementary. So the 3y plus 72, they have to add to 180 because they're consecutive angles, right? So they have to be supplementary in a parallelogram. So I could build this equation here. And then I also know that the 72 and the 4x have to be supplementary. So my second equation that I could build, 72 plus 4x equals 180. And I've built 2 equations which would yield the value for both of my variables. So over here, if I subtract 72 from both sides, we get 3y equals, and if I take 180 minus 72, get 108. Divide by 3, so we should get 36 for y. And then I'm solving my other equation for x. So subtract 72, 180 minus 72 would also give me 108. And divide both sides by 4. And I will get 27. X equals 27. 7. And there we have it. I believe our last one, and this one involves diagonals. If this is in fact a quadrilateral, I want my diagonals to be bisecting each other, meaning this line is cut perfectly in half by this line, which is also cut perfectly in half. So the yellow halves have to equal each other. So 20 has to equal 4y. And then the teal halves have to equal one another. So 15 equals 30x. If I solve my green equation, dividing both sides by 4, we get y equals 5. And if I solve my red equation for x, divide both sides by 30, I should get 1/2 for x. And there we have it, solved for both of our variables. And I think that was the end of our, day 7. Thanks for watching, guys.